Hey tech enthusiast, welcome back to Tech Geek Life. I'm Tanvi and today we are diving into a cornerstone of object-oriented programming, the solid principles. If you've ever worked on the code that seems to break with each new feature or fix, solid principles can be lifesaver. They help you write code that's clean, easy to maintain and less prone to bugs. So let's jump in and see how each principle can help us level up as developers. The term solid was introduced by Robert C. Martin or Uncle Bob and represents 5 principles for writing well-structured, maintainable code in object-oriented programming. Each letter in solid stands for one principle, and when applied together they help us create software that's scalable and easy to manage. Let's go through each one, starting with the single responsibility principle. The first principle, single responsibility, means that every class should have just one job or responsibility. In practice, this means a class should only do one thing. For example, if you have a class called user, it shouldn't handle everything related to users, like storing data, sending emails, and managing profiles. Instead, each task should go in a separate class: user data, email service, and profile manager. By keeping each class focused on one responsibility, we make the code easier to understand, debug, and update without affecting other parts of the program. Next is the open-close principle, which suggests that classes should be open for extension but closed for modification. In simpler terms, you should be able to add new functionality to a class without changing its existing code. For example, if you have a payment processor class that handles credit card payments and you later want to add PayPal payments, it's better to create a new class called PayPal Payment that extends payment processor rather than modifying the original code. This way, we can introduce new features without risking bugs in existing functionality. The Liskov substitution principle ensures that objects of a superclass should be replaceable with objects of its subclasses without breaking the application. Here's an example. Imagine a bird class with the method fly. Now, if we create a subclass called penguin, which can't actually fly, we violate this principle. To keep things logical, we could use an interface like flying bird that only classes for birds that can fly would implement. This way, we avoid unexpected issues and keep the inheritance consistent. The interface segregation principle is all about avoiding large complex interfaces that forces classes to implement methods that are used. For instance, if we have an interface printer which methods for print, scan and fax, a simple printer that only prints shouldn't need to implement scan or fax. Instead, we can split printer into smaller specific interfaces like printable, scannable and flexible, so each class only implements what it actually needs. This makes our code cleaner and more efficient. Finally, we have the dependency inversion principle. It suggests that high-level modules shouldn't depend on low-level modules, but rather on abstractions. Imagine we have a report class that pulls data from a database class. Instead of depending on database directly, report could rely on an interface like data source that database implements. This way, we can change the storage from a database to a file system. We only need to update the data source implementation, not the report class. This keeps our code modular and adaptable. So why should we follow solid principles? These principles make our code maintainable, flexible and scalable. By designing classes with a single responsibility, ensuring they are open for extension and rely on interfaces instead of concrete implementations, we create a code base that's easy to work with and adapt. When you follow solid, adding new features, fixing bugs, and scaling your application becomes much simpler and safer. In conclusion, mastering solid principles is like adding a powerful toolkit to your developer skill set. These principles not only help you write better code, but also prepare you for real-world challenges in software development. So whether you are just starting or already experienced, integrating solid principles into your work will make a big difference. If this video helped, don't forget to like, subscribe, and hit the bell icon for more tech content here on Tech Geek Life. See you in the next one.